Hi everyone, and welcome back to Educator.com. In this mini lesson, we're going to go through the first page of the Kinematics Defining Motion worksheet from the A+ Physics site, which you can find the link for down below. So let's dive right in. A student on her way to school walks 4 blocks east, 3 blocks north, and then another 4 blocks east. Compared to the distance she walks, the magnitude of her displacement from home to school is, well, the distance she walks is how far she's traveled, 4 plus 3 plus 4, or 11 blocks. The displacement, however, is the straight line distance from where you start to where you finish. So that would be the displacement. And the displacement is obviously less than the distance that she walks. So compared to the distance she walks, the magnitude of her displacement is less. Number 2, a motorboat which has a speed of 5 meters per second in still water is headed east as it crosses a river flowing south at 3.3 meters per second. What is the magnitude of the boat's resultant velocity with respect to the starting point? Well, if it's going 5 meters per second east, and it's also crossing a river that's flowing at 3.3 meters per second south, the boat's resultant velocity with respect to the starting point, well, to do that, I'm just going to add these two vectors. They're already lined up tip to tail, so I can draw a line from the starting point of the first to the ending point of the last. Now, to figure out that magnitude, I'm going to use the Pythagorean theorem. To figure out that magnitude, that's going to be the square root of 5 meters per second squared plus 3.3 meters per second squared, which is going to be 5 squared plus 3.3 squared. And the square root of that gives me about 6 meters per second. Answer 3. Number 3, a speedometer in a car does not measure a car's velocity because velocity is a vector quantity. We can get rid of 3 and 4. Velocity isn't a scalar. And because it's a vector, it has a direction associated with it. So velocity is a vector and has a direction associated with it. A speedometer in a car doesn't measure that because the speedometer doesn't tell you that. Above Earth's surface. Now that's a trick question there. Remember, mass is how much stuff something's made up of. In this case, that's not going to change even though its position is changing. It still has the same mass. So our answer, number 2, 2 times 10 to the 4 kilograms. Number 6, an airplane flies with the velocity of 750 kilometers per hour 30 degrees south of east. What's the magnitude of the eastward component of the plane's velocity? Well, let's draw ourselves a little axis here. Y and X. And it's going to fly 750 kilometers per hour at an angle 30 degrees south of east. So if I go south of east, it's probably going to be something right around that. And its magnitude is 750 kilometers per hour. Our angle here is 30 degrees. What's the magnitude of the eastward component of the plane's velocity? So if we want the eastward component, well, that means we're going to want this component. That might be just a little long there. That component of our 750 kilometer per hour vector. And the way we get that? Well, the magnitude of the eastward component of the plane's velocity, which I'm going to call the x component of the velocity, is just going to be our total velocity times the cosine of 30 degrees, or 750 kilometers per hour, times the cosine of 30 degrees, which implies then that our velocity in the x direction, or the east direction, 750 cosine 30, or about 650 kilometers per hour. Answer 2. Number 7. One car travels 40 meters due east in 5 seconds, and a second car travels 64 meters due west in 8 seconds. During their periods of travel, the cars definitely had the same. Well, let's take a look. Car 1, 40 meters due east in 5 seconds. Okay, that means its velocity is going to be its distance traveled, let's call that delta x, divided by the time it took, or 40 meters in 5 seconds, which is going to be 8 meters per second, and the velocity, that'll be east. Our second car has a velocity of delta x over t, but it's going to travel 64 meters due west, so let's call that negative 64 meters over 8 seconds, which is going to be negative 8 meters per second east, or 8 meters per second west. So they have the same speed, but different velocities, because they're going in different directions. So our correct answer, they must have the same average speed. Let's check out one more. State the 2 general characteristics that are used to define a vector quantity. Vectors are made up of 2 things. They must have a magnitude, or a size, and a vector also has a direction. So magnitude and direction gives you a vector. All right, that covers the first page of our Kinematics Defining Motion worksheet. We'll talk to you next time. Make it a great day.